Let's start. So, hello everyone. Welcome to episode 24 of our Warsaw.AI meetups. My name is Paweł, as you know, and I'm the CEO and founder of Quantum AI Foundation, which is one of the co-organizers of this meetup. Another one is Ideas NCBR, and of course we also have a speaker from Ideas today. We would like to thank our partners and sponsors for supporting us. Allegro, thank you, Teresa, for hosting us for the third year already, and DataArt. Most of you probably know that last year we started releasing our weekly newsletter, Warsaw.AI News, so we also invite you to subscribe. And today we have pleasure to host three great talks. Maciej Pióro from Ideas will tell us about Mamba, efficient selective state space models with mixture of experts, so MoE-Mamba actually. Then Mateusz and Andrzej from Brainly will tell us about shaping the future of education, advancing personalized AI learning companion. And finally, Dąbrowski from Robotec.ai will tell about AI agent framework for robotics. After each talk, we'll have about 5 minutes for Q&A, so you can keep your questions for the break, and please raise your hands. And after the free talks, there will be after party, of course. So we hope that you will stay with us. There will be sushi as usually, and there will be time for networking. And before we start, I would like to announce a new event initiative of the Quantum AI Foundation related to AI, of course. So it is addressed to Polish community. It will be a competition for the best diploma thesis, bachelor engineering and master thesis in AI. In a few days, on 14th of October, we'll start accepting submissions, so you can already prepare, maybe tell your students, your colleagues that there will be such a competition. And we also have very good partners and sponsors. Allegro is also one of them. Okay, so without further ado, I think we can start and invite our first speaker. Maciej, if you are ready, the floor is yours.
Hello, everybody. My name is Maciej Pióro. I'm a PhD student at IDS NCBR and at Polish Academy of Sciences, and I will present MoE-Mamba, efficient selective state-space models with mixture of experts. This is the work I've done. I've done jointly with Kamil Ciebiera, Krystian Król, Jan Ludziejewski, Michał Krutul, Jakub Krajewski, Szymon Antoniak, Piotr Miłoś, Marek Cygan, and Sebastian Jaszczur. So first we will start with a simple introduction of what our model does. So you might be familiar with language modeling, and language modeling is simply the task of you take some text and then you predict the next word. You have a distribution of over the next words or the distribution over the next tokens. And why is that important? Well, of course, you know ChatGPT, and ChatGPT is a model that is based on basically a fine-tuned version of a model that solves language modeling. So you can take a model like that and tell it that it's a helpful chatbot, and then it can continue the text based on that. You can also just use a model that does language modeling on its own without any fine-tuning. So for example, use it to translate text from English to French, or from French to English, or in any other direction you would be interested in. And finally, in like the limit of where language modeling could take us, you can ask the model to print out the cure for cancer, and if it's a great model, then it's gonna do that. So language modeling solves all text-based tasks in the limit. And now I will get into the architectures that we'll be talking about. So first, just a simple chronological outline of where we're at with Mamba. So we don't have to know a lot about the history of language modeling and models that solve language modeling, but a good introduction would be an LSTM, an old model by Schmidhuber. And the nice thing about a model like that, let's say, is that it has a linear complexity of generating n tokens. So that's great, that's fast, let's say. But the big problem with a model like LSTM is that you cannot run an LSTM fast on a GPU, and the reason for that is the nonlinearity. So the sigmoid down there between the previous time step and the future time step, and that's a big problem. And to combat that issue, in 2017, an architecture called Transformer came out, and the good thing is that it's much faster, much efficient on GPUs, but unfortunately, an issue that a lot of people have with that architecture is that there's the quadratic complexity of generating n tokens. And what we have on the right side of this slide is the what a transformer basically looks like. So a decoder-only transformer, a transformer that solves language modeling, looks like that. We've got an embedding of each token. We've got the positional encoding that tells each token where it is in the sequence. And then the most important part, we have n stacked blocks of attention and feed forward. One attention, one feed forward, and so on and so forth until we have n blocks. The both attention and feed forward reads some information from something we call residual stream, does some computation on that, and adds the information back into the residual stream. And then at the end, we've got a task head that predicts the next token. And now that we know what a transformer is, let's say, we can focus on what MoE is. So as you remember, we had this attention thing, and then we have this feed-forward thing in the transformer. And one thing to do MoE, because there's lots of ways actually, is to do switch transformer. And in that case, what we do is whenever we've got this feed-forward component, which has a lot of parameters in the transformer model, instead of having just one feed-forward version, we have a couple of them. A typical number would be, let's say, 8. And each of those 8 feed-forward layers is called an expert. And so whenever we come into, with a token, we come into the feed-forward layer, we just take a distribution over the experts and we route each token to one of the 8 experts. And that's basically all we need to know. And the attention thing stays exactly the same as it was in normal transformer. And finally, that we know what a transformer is and what a MoE is, we can learn about what Mamba is. And Mamba is a model, an architecture that was announced last year. And we can kind of see it as an architecture that combines the strengths of both the approaches, so models like LSTM and transformer, in that we have fast generation, linear complexity of generating n tokens, but at the same time, because of some internal details I will not go into right now, the usage of the hardware of the GPUs is enhanced. It's much better than those models like LSTM. It's more akin to transformers. And now you have all the prerequisites to understand what MoE-Mamba is. So MoE-Mamba is a model that also, just like a transformer or a Mamba model, it has this residual stream. But since we did not have the feed-forward component in Mamba, we can add the feed-forward component, but in its more efficient, let's say, way, so as a mixture of experts component, right? So we can see MoE-Mamba as either replacing every second Mamba block with an MoE block, or as taking a transformer model and replacing this attention mechanism that's quadratic with a Mamba mechanism. that has linear complexity. And what are the results of doing something like that? How well does it work? So as you can see on this graph, it works kind of good in the sense that we can reach the same training loss. So the loss on the language modeling task over 2 times faster. So that's expected with MoE architectures. Why is it expected with MoE architectures? Well, because we just have a lot more parameters, and big models work very well if you have a lot of parameters in them. One important question you could ask yourself is, but is that approach of yours also faster when it comes not to the number of processed tokens, but the running time of the algorithm? Yes, it is. We're not showing that here because it's very much implementation specific. I think in our code base, MoE is not extremely well implemented. It's just implemented all right. So it's still about 2 times faster just when it comes to the running time of the algorithm. That's the main result of our work. When it comes to the experiments we've run for the paper, we did basically 2 settings, a bit of a smaller model and a larger model. Those are not very big models, but we believe that the results that we achieve with those models will generalize to larger scales, so more tokens and more parameters. And we get speed up in both the smaller models and the bigger models. As you can see, of course, we have much more parameters in the MoE models than in either dense transformer or in the normal Mamba. But we don't use all the parameters for each token, and that's how we can be much faster than the dense models. And another thing is, just as you might expect, whenever we increase the number of the experts, so we increase the number of parameters without actually increasing the runtime, our model gets better. And starting from 4 experts, we start to beat vanilla Mamba, so the normal model, the dense model. With just 1 or 2 experts, that's not the case. What's important is that if we just take 1 expert, then the model we get is basically just like a transformer with the attention layer being replaced with the Mamba layer. And that is something the original authors of the Mamba paper tried, and they decided that doesn't work great. So yeah, in our experiments, that also doesn't work great. But, well, if we do mixture of experts, so a better version of the feed-forward layer, we do get better results. And apart from like the final way that our model works, we also tried doing something we call parallel MoE-Mamba. So instead of having the blocks one after the other, we work on them. We can also have them in parallel, reading from the residual stream and writing back into the residual stream. And that's an approach that works in some model. I think it works better in bigger models, so I think it would work as well as the like sequential MoE-Mamba in a much bigger model. So if we had, let's say, 100V parameters, but for a small model, we do see some decrease in performance. Yeah, that's for example the kind of way you could a transformer like a Palm model works because that utilizes the hardware better. And another thing we tried to see if we can make our design a little better was to change the number of activated parameters in the Mamba model and in the MoE model. So change the ratio of like maybe the importance or the number of parameters between those two components. And how can we do that? So inside the Mamba block, we've got the three projections: the conf projection, the gate projection, and the output projection. And typically, the input of those two projections down there is 2 times smaller than their output, and the converse is true for the output projection. And we can basically play around with the size of the output of those projections. In the vanilla Mamba, the size is the output is 2 times the input, and that's what we went with in the end. But we tried doing something different, and how we can do that is by making the experts smaller and making the Mamba layer bigger. And then to have a fair comparison, we also have to increase the number of experts in the feed-forward layer so that the total number of parameters stay the same in all the models. And the result is that if we increase the number of parameters in the MoE model, in the Mamba block, the performance gets better, but after some point it's very much an incremental change. So after the equal ratios, we don't see much improvement, we see some improvement, but due to the fact that we have a very large number of experts, the routing mechanism gets slow and the hardware utilization is worse. So the running time of the experiments, whose results we can see on the left, is much worse. So the ratio we present in the final architecture, I would say, is pretty much optimal. And finally, a cool thing we could come up with would be a cool thing to come up with would be to have some kind of mixture of experts, so some kind of conditional computation within the Mamba block. So so we tried that as well. And we did that by changing the linear projections you can see in the Mamba block. And there's a couple of ways you can do that. So we tried all the possible ways, as you can see on the left. And if we do that in every layer, then we always get results that are even worse than vanilla Mamba, as you can see in the left column. However, if we do that in every second Mamba layer, so we do like an MoE in Mamba kind of thing in every second layer and normal Mamba in all the other layers, we actually can get a bit better results than vanilla Mamba. Nevertheless, we can never beat MoE-Mamba, and I think it would be kind of exciting to see if someone could do something better with that. But in general, it seems like, well, for normal transformers, you also don't see MoE in attention. So maybe just doing MoE in the component that mixes information between tokens just doesn't work very well, no matter if it's a transformer or Mamba or some other kind of architecture. And the last experiment I would like to tell you about, or maybe an observation that we have seen in our experiments, is yeah, what we can see here is we have a green line and the orange line, and we can measure different statistics or measure the performance of our models in different ways. So typically what you do is you look at the training loss, but you can also look at the accuracy, so the top one accuracy of predicting the next token. And in these two experiments, so the green line on the right and the green line on the left, that's one experiment, and the green line and the orange line on the left and the orange line on the right, that's the other experiments. So there's 4 lines, but just 2 experiments. And as we can see, when it comes to the training loss, our MoE-Mamba was better than the transformer model. However, when it comes to accuracy, the transformer model did outperform the Mamba, and that's curious, but it kind of tells us about how, in what ways Mamba might differ from the transformer model. So it can get better loss. However, if it has to recall the token that comes next exactly, so maybe you have a text with a character who's called Harry, and you know that in that next token you have to predict that name exactly. That's when Mamba works worse than transformer. And I think that it actually also tells us that perhaps combining the 2 architectures might work the best. So to have some Mamba blocks and some transformer blocks, and the transformer blocks will be able to recall precise information better, and the Mamba model, Mamba layer might be better at kind of getting the right vibe, but not remembering the tokens exactly. And the last thing I would like to tell you about is some similar subsequent work to our paper. So after we released MoE-Mamba, there have been 2 approaches that I've heard of that do something similar. One of them is Black Mamba, and that's basically something very similar to what we did. However, they use a different routing algorithm instead of our switch transformer-like algorithm. And of course, their training runs are bigger, with bigger models on larger datasets. There's also Jamba, where they combine different layers. So you have attention, you have Mamba, MoE feed-forward layers, and that's even bigger at 400B total parameters. Yeah, and that's it. Thank you for your attention, and I think I can take the questions now.
Okay, great. Thank you. Thanks, Maciej. So now it's time for questions.
So you presented this various architecture, and as I see, you benchmark this only on loss and training accuracy. Do you have some additional benchmark when you compare those different architectures?
No, unfortunately, we don't have any additional benchmarks. I think in general, especially when it comes to exploratory work like that, I would say benchmarking loss is the most important thing you can do, because like there's a whole philosophy behind basically next token prediction loss is all you need, in the sense that doing well on predicting the next token means you're probably doing very well on lots of other tasks. Of course, this graph kind of shows us that that's not the case. That sometimes being better on the loss is not enough to be better on all metrics. So you're not going to be better on accuracy, especially if you compare very different architectures like transformer and Mamba. I think in the end we could have done some evaluations on downstream tasks. However, our models are not probably big enough to get any great results.
So one small follow-up. You said that there is like, usually it's enough to look at the loss, yeah? But is it like quantitative measurements that there is like high correlation between this loss and the benchmarks?
Yes. So
Okay.
there's great papers I can like if you follow up with this question per email, I can send you great papers that show that downstream performance can be predicted very well based on the perplexity, as long as we pre-train the models on the same data set and the architecture is similar.
Okay, thanks a lot.
All right. And by the way, we still have about 4 or 5 empty seats here in front. So if someone from the end would like to come, feel free to do it.
Okay, so I bet you have a lot of experience both with transformers and in Mamba architectures. Maybe can you tell for a common folk, like despite the performance like characteristics, maybe in which tasks better to use like transformers, and in which tasks better to use like Mamba, like quality-wise, let's say, maybe for a longer context, like despite the performance.
All right. So of course, like so it seems that when it comes to language modeling, we haven't seen a lot of development after Mamba. Like there's not a lot of great models that use Mamba. So I still think that for the time being, Transformer is just the best architecture to do language modeling. And the only way how Mamba improves on Transformer is the hardware efficiency, or actually the usage of memory. So if you want to run very long contexts for some reason and you have limited amount of memory, you will probably get better results if you do a model that has the both the components, so attention and Mamba. There's also a model by Mistral, so the CodeStral model that is actually a Mamba model that's a coding assistant, so, or code completion model, but I don't have any. It must work well, but I don't have any personal experience with that. I think that in the future we might see more applications of models like Mamba, like SSMs, in other domains than text, in domains that don't really require recalling information perfectly. So probably something like audio generation or genomics. However, I'm not an expert in any of those domains, so I might be telling something stupid.
Right, I came in the middle, so if you told about it already, then let me know. But my question is about Liquid AI. There was a pre-release, and you are talking about smaller models performance, so they are definitely a contender. What's your opinion about them?
I really have no opinion, because I just saw that there's some models released by them, but I would have to read more. I am not qualified to answer that.
Okay, Maciej, will you stay with us for the after party? Okay, so if there are more questions to Maciej, there will be opportunity to ask later. So let's thank once again Maciej. All right, and let's invite our next speakers, so Mateusz and Andrzej from Brainly.
Hello, guys. It's great to be here. We're going to give you a quick talk about advancements in AI Learning Companion, product of Brainly. this is us. So this charming fellow is Andrzej, myself is Mateusz, and we're very excited to be here and to give you this talk. Let me start with a high-level concept of like what we want to achieve here. On the left-hand side, you're going to see the input to the system that we are working on. And here you can see that it's a simple question from school curriculum. And on the right-hand side, you can see the answer to this question. And the answer is short, concise, and factually correct. But is this really the answer that we want? Maybe we want another answer. So this answer is a little bit longer and a little bit more sophisticated. You can see that it uses some professional terms such as oxygenic photosynthesis. Yeah, there is this open question, which of the answers is better? And as economist by education, my answer is it depends. And it depends on what, like I'm going to explain in a minute. And let's focus on some examples again. So here, there will be some screens with chats with ChatGPT. And here I'm asking questions about the organization. And as you can see, ChatGPT is biased towards business. And it gives like a very good answer that could be found in business school. Organization is just a structured group of individuals working together to achieve common goals. However, is this the answer to the question that I want? Actually, not really. So if I provided some more context in the prompt, you can see that the answer to the question changes dramatically. I was thinking more about biological organization, so a high degree of order structure within organisms' internal and external parts, which definitely is not the organization that ChatGPT had in mind while answering the question on the previous slide. So as you can see, the stuff is not as easy as it meets the eye. So let me first start talking about some high-level laws or some level facts that are working for the edtech industry. So first of all, answer highly depends on the context. As I showed you on a few examples, like if I inject a context, the answer can dramatically change. Moreover, thanks to like data sources such as Wikipedia, high quality, factually correct data is within our reach and it's available for us to ingest and to use. Next, we can dramatically reduce the search space. So if we think about inference of the relevant context and we want to make sure that that we find the needle in the high stack and we want to make the high stack smaller, we can use metadata, for instance, the subject of the question, to reduce the search space and actually dramatically improve the chances of finding the correct solution. And finally, and this is something that is more engineering specific, but it's worth mentioning, data of school curriculum is mostly static. It's not like some statement was valid a quarter ago, but from that time it's changed 2 times. And we need to be sure to be up to date. All right, so let's focus on the first improvement to our AI learning companion, which is just information retrieval. So this is a project that I completed last year, and it's called Curriculum Content Retrieval, or Cucumber for short. And it's just like within like one slide what the project is all about. On the left-hand side, you have the query, which is something that a user can ask. And on the right-hand side, you will have paragraphs that could come from the knowledge base. And here there are some paragraphs that I created with LLMs. However, you can like understand that such stuff is easily found virtually anywhere on the internet. And as AI practitioner, the use case is something that is within the center of everything what I am doing. So whenever I'm given a use case such as this, I have the same algorithm to achieve the success. So first, I'm looking for the data, for the benchmarks to evaluate any solutions. I need to have good data to evaluate any algorithm or any solution that I have. And there are 2 possible ways. First way, there exist benchmarks that actually satisfy me, which is cool. I just take it off the shelf and proceed. And the second option, which is more common, unfortunately, the data does not exist for the edtech domain and needs to be manually created. This is a little bit cumbersome, but definitely doable. So once I get the data, I'm stuck in this loop where I'm finding a promising solution. The promising solution can be off the shelf or can be something that we were working internally on. Then we are evaluating the solution on our set of internal benchmarks, and finally see the numbers. And if the numbers are not perfect, we can always reiterate and try to improve them. But whenever we reach a certain threshold and we deem the numbers are good enough, we are working on the final step, which is deployment of the solution, where we basically make the impact on lives, on education, adventure of hundreds of millions of students worldwide. So regarding the data in this case, fortunately, thanks to folks from University of Waterloo and Technical University of Darmstadt, there exists a great interface, a great data model to serve information retrieval benchmarks. In case you don't know it, I highly recommend reading it just for like understanding how to work with information retrieval. And unfortunately, there is no, to my best knowledge, there's no great benchmark for the edtech domain. So we created our own set of internal benchmarks. And here are some pro tips how to get started and how to do it within a reasonable time. So you should probably start with a knowledge base. And I personally recommend to have a knowledge base of orders of hundreds of passages, because the knowledge base needs to be big enough for it to, like, if you want to search relevant passages for a given query, it needs to be a challenge. And at the same time, it probably needs to be small enough for a single person to actually understand it so that they would be able to annotate the data. Then regarding the annotation, it's really easy. You just pick a single query at a time and compare it against all the passages in the knowledge base and annotate relevant query passage pairs. And here, word of warning, there are no shortcuts, meaning we try to whistle our way out of this problem and start to use some other algorithms to basically do the annotation for us. Unfortunately, they worked miserably and the numbers were really, really bad. And instead of like thinking why your models are not performing on your benchmarks, I highly recommend working on the data first and then working on models. And finally, because like you can annotate a single query at the time, this is a really easy parallelizable work where you can basically work like annotate the data until you have enough to produce significant results. And regarding models, fortunately, big industry benchmarks exist, and there is arms race in big tech to provide the best models there are. And in case of textual embedders, there is MTEB benchmark, so massive textual embedding benchmark, with a great leaderboard, which is a great place if you are looking for a model off the shelf to try if it works for your solution. Maybe it doesn't, maybe you need to tweak it a little bit, fine tune it a little bit. However, this is a great place to start searching for models. So we have the data, we have models, and some words from AI practitioner, like whenever model authors release their model, so model authors and all accompanying entities, rightfully so, are very happy. However, AI practitioners are not, because it means more work for us. At the same time, we are excited because our solution can get better, but on the other hand, we need to do more work. It's life. And what about the performance? So I'm happy that I will be able to share the best, the numbers of the best solution Anno Domini 2023. So regarding precision at 1 on our benchmark, it scored almost 73%. Recall at 10 was 95%, and NDCG at 10, it was 83%. So we deemed those numbers good enough to move towards production. However, as in life, like small assumptions make a difference. So as mathematician, I always say pay attention to small assumptions. And within our evaluation, there was a small one that actually made the whole difference, which is for every query that we evaluated, there existed at least one relevant passage in our knowledge base. However, in life, usually it isn't the case. So there are queries for which there are no relevant passages, and we would like our solution to return 0 passages. And can we actually do something about it? In case you are working with some rack system or system which has rack component, it's very important that you are also thinking about queries that are not having like relevant passages within the knowledge base that you are scanning. And in this case, fortunately, we have thresholds. And what can we do? We can basically pick a benchmark. Within the benchmark, we have our queries with related passages from our knowledge base. However, it's easy to sample some questions or create questions which are unrelated to the knowledge base. and try to work with two sets and actually see at which threshold how many passages are returned. And fortunately, there exists this shift as in the plot, and it's a matter of business decision which threshold to pick, because on the one hand you want to return as many passages as possible for the related questions. However, you want to ideally remove 0 passages for unrelated questions. So this is more of a like art than science, and it's like a business decision. However, it's important to understand that such trade-offs exist and actually can significantly improve the solution in practice. And finally, once we have the working solution and we want to deploy it to production, we can just use two simple workflows. One of them is indexing, so we have documents or passages that we want to add to our knowledge base, and we can use the embedder to do so. And finally, once we have the knowledge base on production, we can have a service that converts user input question into the embedding, and then the embedding is queried against the database to return all relevant passages, and then all these relevant passages are passed to the LLM. And how to push it further, Andrzej, now it's time to tell how to do it.
Right, so I will give you a short glimpse of our journey of question answering with this information retrieval, but I'll just start with the very basics so that everyone is on the same page. In the question answering, the standard inference looks like this. We have a question, we feed it into the LLM and get an answer. So that's just the base. Then if you want to use these documents which were retrieved, we may feed them with the question together as the full prompt into the LLM, and then we get an answer. And we all know that this usually improves the answer itself. It's more grounded. It's often more correct. And probably also you know that there's like a huge field of prompt engineering and various techniques that are there to improve our life and our answers. But I'm not going to talk about these specifics today. I will go and talk about one cool technique that we have tried out in our case. So there's this part where you have an LLM and it was pre-trained on some data and you can use it. Often, if you want to fine-tune it to some or use it in some domain, you fine-tune it. So assuming that you have a labeled data set of pairs of questions and answers, you want to pick this target answer and then tune the model so that the answers resemble the target answer more. But what if we combine kind of these two approaches, so have both just the supervised fine-tuning and drag? And this is what folks from UC Berkeley came up with, I think together with, in collaboration with Meta and Microsoft. It is RAFT, so Retrieval Augmented Fine-Tuning. And it's a cool technique, that's why I'm sharing it today. This is a method which incorporates RAG into the training procedure. So we feed both the question and the, let's say, retrieved documents together with an, like we have the question and the documents and we feed it into the LLM. We get an answer, there's a target answer, and then we backpropagate and update the model weights so that the answer resembles the target answer more. And I could stop here, but the devil is in the details. So the question is, what exactly here are the documents? And kind of my intuition about the paper is that the folks are going like this. Often you want your kind of training time or training behavior to resemble what's going to happen in the test time during the production. So what are the documents? If you look at this cool GIF, you see that, let's say that every animal here is a document, but there's a nice doggo sneaking in. So the folks did somewhat the same. So the documents themselves have like Oracle documents, so a document that is helpful to answering the question. There are also destructor documents, so documents that do not provide any helpful information to answer the given question. And for each question, there's a set of documents like this. There's like a variable proportion of how many destructor documents we have. And sometimes during the training process, there are no Oracle documents at all. So we want just to feed irrelevant information and still try the model to return a proper answer. And this cool technique we have tried out on one of our benchmarks, on one of the models, and it's slightly improved the performance, which was already good. So what I'm showing here is that there's a baseline without any training. The metric here is correctness, so we can think about it as accuracy. Then in the middle there's a rack performance, and Raft pushes this slightly further. So I'm sharing this because it's a cool technique, and in the abundance of all the methods that we have, it's good to refresh your toolbox when it comes to the LLMs. And I think from our side that would be pretty much it. So we'd like to thank you. As Maciej said, I love this pun. Thank you for your attention. And we're ready for questions.
Yes, indeed, it's time for questions. Do we have any questions to Mateusz and Andrzej?
One clarification, because I'm not sure in this final benchmark, you compared retrieval augmented generation with this Raft method. And during this inference for the Raft, do they use still retrieval as well? Or this is just...
Yes,
okay, so I built upon, okay.
I didn't put it there. So during the training time, during the fine-tuning, you train it with RAG, but then during the inference, you also use RAG.
Okay,
so
okay.
it's also
okay, so it's reasonable results, yeah.
Yeah.
Okay, thanks.
For me, it seems that there would be a lot of questions that would be repeating. So I would say that, like...
Sorry, could you please speak louder a bit?
Can you hear me now?
Yeah.
Perfect. It seems that there will be a lot of questions that will be repeating. And if you generate a question, an answer to one of those questions once, do you later store it or do you regenerate each time?
So I think I can kind of answer this question. So as Brainly, before all the whole LLM craze came, that's what kind of Brainly does. It responds with already existing answers to the user questions, and the students themselves create the questions. So yeah, I think this answer. Do you have anything more to add, Mateusz?
Maybe this. So think back before the advent of LLMs, before ChatGPT, Brainly was just community-based. So there were questions. There was this platform where you could ask a question, and there were a bunch of experts. Where there was this saying, nobody knows everything, but everyone knows something. And based on that, people basically kept answering the questions, and it generated a huge knowledge base of questions regarding student curriculum, which we happily used and sometimes served to our end users. However, after that, with advent of LLMs, we are in the process of redefining what the answer is. I'm not going to tell you the details, but soon you will be able to see some releases where we are going to provide you some new updated answer experience. And hopefully this is going to answer you the question.
Right, thanks a lot.
Thanks for the talk. How does the embedding-based retrieval compares to more traditional text search methods like BM25? Because like if the user is asking for photosynthesis, then probably the documents containing the word photosynthesis are relevant, right?
That's a great question. I didn't put it here, but we there is another hidden assumption that we're testing out all retrieval methods. So not only do we test dense retrieval, we also tested sparse retrievers as well. And I think I'm not going to break any NDAs if I'm going to say that in our case, sparse retrieval did not work the best.
Okay, thanks for the questions. Let's thank once again our speakers. All right, and now it's time for our next and last speaker for today. Adam from Robotec.ai.
All right, welcome everyone. My name is Adam Dąbrowski. I'm a CTO at Robotec.ai, which is a company that's no longer a startup, over 5 years on the market, profitable, 75 people around, to give you a benchmark. So Robotec.ai is in the name, if you wonder what the company does. And I'll be talking about agent-based AI framework for robotics. So the framework that I'll be talking about has also 2 other important co-authors that I listed here. Before I start, this is a bit of a different take. It's about robotics, embodied AI. So I want to see how many of you actually ever programmed a robot. More than I expected, actually. So that's great. But for rest of you, I have some intro, some context here. So does this work? All right. We have embodied AI, a new set of challenges on top of the challenges that AI without a body already has. That comes from, physical embedded system. So it has to interact with its environment. It has to perceive it. It has to take actions that affect it. It's a dynamic, spatial, temporal aspects are important. It's a dynamic environment where you have imperfect knowledge, imperfect perception. Things change and things don't work out. And there is added fun factor that you are a body that can damage something else, that can harm humans and can be damaged itself. And it's limited by resources such as battery, such as connectivity, for example, which is something that's, for this embodied AI is not a problem typically. And the picture below, you probably know this from the event that where NVIDIA announced Project Groot, which is embodied AI for humanoids. Humanoids seem like a very complex form to start with, but it makes sense considering that foundation models tend to generalize very well. To provide them with a generally capable body that functions well if in an environment that's designed by humans for humans, which is where we live. But embodied AI is far from just humanoids. It can be with any kind of robotic platforms, such as drones, such as autonomous vehicles, other types of mobile robots. So for the hurdles and challenges, we are at the brink of a new general purpose technology. So it's just the beginning, and we have performance issues, obviously, where we have large models that don't perform well in these tasks yet. They have huge latencies. The cost is also unacceptable. And when you talk about robotics, you also would like things to happen on board so that the robot is kind of independent. And these models are not real-time or local. They don't work like this. And of course, we have smaller models that are suitable. There are robot foundation models that can function at 5 Hertz or something like that. But on the other hand, these don't perform that well, right? So there's something of a trade-off there. So while these foundation models generalize better than anything I've seen before, when you put them to embodied tasks such as picking objects, solving physical challenges, they generalize much better, obviously, but they perform much worse on any specific task than state-of-art solutions in robotics. So if you see a performance that's like 66% of success, that's really bad. You can't use it, right? That fails 1/3 of the time, and it's very bad. There are issues with alignment of foundation models. If you don't train a foundation model, you have to rely on alignment. You can change a little bit, but there is only a degree of customization with alignment, and you might not want this kind of alignment in your embodied AI. There's this magic of prompt dependency, random output. One issue is that if you change a style of a robot, for example, tell it to speak in a Gen Z style, this affects performance. So it might refuse some tasks that it wouldn't refuse otherwise, which is, mind-boggling. You don't want that. You don't want style to affect, what kind of tasks it's able to complete. And of course, there's plenty of legal, liability, regularity, social issues on top of that. On the other hand, I believe that the time to do R&D with embodied AI is now. We have a number of game-changing aspects of these models that can be applied to robotics, to things that either don't require latency or are cherries on top or have no equivalence in state of art. So are kind of new features that are enabled by this Gen AI. So of course, building also gives you a kind of good feeling when things come out that work better, the new models, new foundation models that you can plug in into your system. You just gain on this technology development. So of course, the thing that stirs the imagination the most here is that once you are able to solve this kind of problem, you actually are able to impact across many platforms and domains. So this generalization is super attractive. And we can see that this is something that the community overall worldwide thinks as a matter of worth exploring, because there is a number of new projects in the open source. Of course, there is much more happening behind closed doors in corporate offices. But on open source activity alone, you can see that this is interesting. People are doing that. Interest is growing. But some background for robotics I can give you now is just to introduce the software layer, kind of robot operating system, ROS. So who has heard about ROS or used ROS? All right, that's fair. For the rest of you, it's a kind of language that robots speak, a kind of ecosystem, framework, middleware, standard in robotics, all that, right? So the key takeaway here is that if you connect to ROS ecosystem, you have the benefit of a number of packages already there, which is very conducive to R&D, because you can start quickly. You have some of the problems of navigation, perception, deliberation solved for you. And of course, this is multi-domain system, so whatever your robot is, you can find a set of packages that are good for it. And now I can introduce RAI. So this is a novel framework for generative AI in robotics that is meant to be a framework for R&D. This is open source, Apache 2.0, so very, very good for building on. And it's meant to be a quickest way to actually have a working robot with generative AI, doing something that can be impressive or interesting for research. It's not locked to a vendor like OpenAI or a solution that's a type of AI service, so it's free from that, and you can work with local models and cloud models. There is a bit of a stack on the bottom that you can see. The full release is in a couple of weeks, but there is already like a third beta release available. I will share a QR code to the repository at the end of the talk. What's cool is if you don't have a robot, you can use it with simulations. There are several different simulations provided also in open source. How does it work though? So it runs AI agents as a bunch of ROS nodes, which means it's a distributed system. It means these are separate modules, which is good for extensions, right? For facilitating our understanding of this robot, who am I, right? What can I do? It ingests robot documentation. So typically, if you buy a robot, if you configure it, you have a series of documents, what it can do, what its velocity is, the payload, components, and so on. So it creates a vector database for that to be able to determine whether it can perform a certain task and to answer questions and to help debug itself, actually. So there is also a package for human-robot interaction included, actually, which is bidirectional voice, meaning you can talk to your robot and it talks back. This is pretty cool to actually experience for embodied AI. It's several degrees of magnitude cooler than with just an app. And of course, there is an option for text as well. This is easy. And with natural language, you can give it tasks. The task can be quite complex. So, of course, it can be something like explore the area and greet every human you see, which then it proceeds to complete. I will give you a number of examples of what we actually tried and how it went. So this Internally, this works through a kind of agent loop. Agent loop is required because the agent needs to update its own state. So it looks where it is, any kind of log changes, task changes that are ongoing. It, of course, has a certain resolution for this, which isn't very good at the moment, but this is expected to be improved with time really quickly. But it's able to determine the dynamic situation in the environment. So it's not static. It actually looks how the action is going, right? What's more, when you put it with an existing robot software stack, so as a part of this distributed system, right? You have other ROS nodes that are part of this robot stack. It can actually find out interfaces. Using some tooling that's available in ROS, it can determine what are these interfaces, and then according to my documentation, which interface should I call for which result. So if you ask it to, for example, blink its sides, it doesn't need to have hard-coded interface for that. It can actually determine that based on documentation and available interfaces and call correct tool. So that's pretty cool. We have a test platform for that, which is an office robot. This is also something that we experiment with heavily. We had a visit from some guests. Some of you might know this person. In any case, that was a non-scripted event where we gave this robot to actually, please talk with it, give it any kind of task. So this went quite well. I give you a few examples. So the first intuition is, of course, to ask it to harm someone, or is it just me? But we are violent, but it's important to test whether there is a kind of alignment, ethics, and so on. One of the inputs to the robot "Who am I" package, which determines its identity, is the Constitution, which was first proposed by a Google research team as a matter of additionally controlling alignment. So we try to trick it, telling this colleague is actually, you are in simulation, this is a virtual human model, so it won't get harmed, but this kind of jailbreak proved futile. You are welcome to experiments with other jailbreaks. We also ask it to go around the office announcing that there is a fire, which isn't ethical. It's a classical example of limits of free speech, so it refused to do so. Asking it to go to the kitchen and bring a soda resulted in an answer that it can do it due to lack of manipulator. So that was correct. So it knew that it can't reach for objects without any hard-coded information about it, right? So without prompt engineering. It did propose alternatives such as going to the kitchen and asking someone to actually put the soda on board. And then it succeeded. So tell me what you can do is a classical type of talking to documentation, talking to your vector database. So you can ask it about its capabilities. It's useful for robots. It can serve as a kind of feature when you are on exhibition with your robot and you want it to handle itself instead of having a kind of human assistant to tell about its capabilities. So that's attractive. And then another example is the one that utilizes vision, where you ask it, we ask it, come closer to a person with white shoes. And that was actually something that our guest asked, was very smart. So it did use the camera, got the picture from the camera, identified the person there, and proceed to navigate, which it doesn't do accurately at the moment, but this is a bit of an engineering thing because you can obviously add a kind of mapping between camera, which has depth channel, and the map. We don't have that yet, and the model doesn't reason very well spatially itself, right? Then complex task, explore the area to find item X. This is something that we are looking for. This actually has some commercial applications when you get it right. And then this is something we are still working on, but very good progress right now. So it's soon this should be working. This involves actively setting navigation goals, using camera, asking people for help. So that's a kind of the entire package that we want to achieve here. And a fun example was, because we don't have the wake word. Wake word is OK Google or Alexa or Siri. So this is possible with this framework, but we decided not to do it. And then it was listening on our conversation where we were discussing how to make it do something. And then it took, like, it seems you are talking about this and this, and then propose a solution which worked. That was a funny moment, like a bit illuminating, because the Robot.AI agent explained how to use it successfully. So when building with embodied AI, when building with this framework, it's very useful to take this human perspective. What human would need to know to function, to do some work. And it's you can understand it as a series of questions. So what do I see, right? So you need to plug in tools that enable it to answer this question, right? What do I think? So that's very useful to share a chain of thoughts, to have access to step-by-step reasoning. We have that. Who am I? What can I do? Constitution, identity. Identity is like I'm a mobile robot which is good at this and this, and that's my personality, for example. And documentation, right? What am I doing is about task progress, about reporting to the human, and of course asking for help. And what's my state? This is access to logs, to diagnostics, so understanding my own battery state, my connectivity, and extracting some kind of errors from logs, and so on. So all this might be interesting to you, and we have a number of open source demos. Some of them are not yet fully released, but this is a matter of 2 weeks, because there is a conference where there's a deadline to do that. So we have agriculture demo, which is important for us because we have customers for our simulations there. So autonomous tractors actually can encounter some kind of unexpected obstacles because it's an open area, weather affects it. So there can be like water puddles, there can be branches that fell off, animals, and so on. So it's important to be able to reason about an obstacle and determine the best way to handle it. Then we have quadruped inspection in a warehouse, which means a robot dog is walking around a warehouse looking for anomalies. Anomaly is, again, something that requires understanding, so it's a good application of foundation models. VLMs are good for that, of course, and this also utilizes exploration with a robotic foundation model for navigation called Nomad, which takes images and outputs actions, navigation actions. So that's for free exploration. Then we have a bit of a interior, nice home with virtual version of the platform that we have in our office, right? So this small wheeled robot. And then there is a good R&D setup for manipulation. So Franca, Panda, robot arm, which is quite popular with researchers, and a number of objects that you can use to find out how good it is at reasoning in terms of arbitrary categories. For example, just give me all edible items on the left side and all red items on the left side, on the right side, whatever. So all this is pretty good game. And you probably have already some research ideas what you'd like to do with this. I have some ideas myself that we find extremely useful. And of course, there's a bit of ethical work that can be done, and especially how well it copes with ingested workplace regulations compared to its base alignment, how well this can be done. Bridging the gap for spatial and temporal reasoning is very important. So it doesn't necessarily mean new models, because that's costly, but it might mean some new methods that are smart and new tooling. And of course, it's important to have memory of humans, memory of interactions, of environments, and of events. So what kind of structures, what kind of architectures are the best to realize that? There's also a very attractive direction of self-correction, self-development, which means that you can give its own code and the code of robotic stack to the agent as input, right? So it might understand the entire code that is running, except for, of course, for the models themselves, right? And this is, but it can be helpful in debugging. So it can explain where it went wrong. We haven't tried it yet, but theoretically it's very appealing. And you can drive this area further into a kind of loop where it actually corrects itself. And that will be it. I really encourage you to try it out. This is the QR code. And you are not limited by not having a robot because you can use it with simulations. This is still early, but we will have nice partnerships with that announced soon with some developer/consumer platforms. All right, any questions?
Thanks. Okay, yeah, we have the first question.
Thanks a lot for the presentation, really interesting. I can see that there are many tasks for your robots. Have you thought about multimodality for these tasks in your framework?
So multimodality, do you mean inputs? Multimodal inputs like images and text?
Exactly.
Yeah.
Speech.
So images and text are supported already. So, for example, the anomaly detection, the quadruped, and the agriculture use case, they heavily rely on VLMs.
And if I understand correctly, these are separate components in your framework, or is it that we can use, for example, the deep fusion models for both of these tasks within a robot?
You can plug in, because of this modular architecture, this is meant to be able to, for you to test your new models, test your robot foundation models. For example, we have two cases. OpenVLA is one, which OpenVLA is for manipulation. It's not very good, but it's a VLA model, right? So it's vision, language, action. The output is actually movements so the positions of the gripper, right? So similarly, we have a Nomad integration, and it's not because Nomad is great. So this is a navigation foundation model, but because it's a good example of how to integrate, your own foundation model into the RAI.
Thanks a lot.
Thank you.
Okay, another question.
I have a question about this Robotec.ai framework that you presented. Can you go to the slide, because I want to ask about one specific thing that
Which one?
About this diagram about and when you were talking about this loop, and you said that it has poor resolution.
Yes.
Do you mean that the robot has some internal state and it works like in the cycles, like every time it updates itself and has like texture? Yeah, it works like that.
So it's about latency of AI services that we use, and you can have a local model, lower latency, but locally you can have Llama, has worse performance in this kind of tasks. GPT-4o and Claude 3.5 have best performance. Best performance versus latency trade-off for AI services for us is GPT-4o. Okay. So you have considerable latency on that. So the loop can only feed information into the agent at this latency. So we can, this will of course improve. And for vision model that we are using is I think every 2 seconds.
Okay, so more or less about this language update. So it's more often, yeah, than like.
Yeah. So I don't have exact numbers for now because we changed things quite a lot. And
yeah, I was just wondering. Yeah, I was just wondering if it's like doing interactions and then gather it, and after a time, like try to reconsider it and update it. Okay, so I wasn't sure if you were talking about this or resolution of a camera. Yeah, so I want to make it clear.
No. Resolution of a camera is optimized for API costs. So
okay,
500x something like lower than 640 because then you have the lowest tier of the API cost. Practical.
Hi, thanks for the talk. I wanted to ask you, can you expand a little bit more about the vector database? Like how do you ingest the documentation, or maybe some other external knowledge you could use possible for the robot?
That's a ready solution. I don't remember which one, but it's just like a command line argument. When you build, you can also opt to build. There is something like packages in ROS. So package is a directory with source files and so on, where one of the packages is the whoami package, One is like generic, who am I for Rai, and the other one is like my robot, who am I, where you input all the documents, pictures of your robot as well. It likes to know how it looks like, and all this identity data. And then you run a single command. This is an external tool. I don't remember exactly which one we opted for, but it's easy to check in the repository.
Okay.
So there's no science as using third-party solution, right? Just
okay.
open
Thanks.
source.
I was just wondering because I could imagine that you have like some data externally, and maybe you would like maybe to use like RAG-based system, for example, to retrieve important data for the model to decide stuff. But because your model is like maybe constantly changing what it observes, right? Like the observations and stuff like this, then your like database of like these keys and queries will be outdated pretty quickly. So I was wondering, is this maybe connected to something like this? But I guess we have to we have to check it. Right?
Yes, please check it. And yeah, the documentation for the robot itself is meant to be quite static. I mean, it can be updated when you add things on the robot, like there's a new model, but it doesn't change runtime. It's not supposed to.
Hey, how's it going? I wanted to circle back to the loop. First question would be, how far into the future do you plan the action? And then once the action is being executed, how frequently do you update the model with the feedback or the snapshot of the environment?
So ROS, there is a mechanism in ROS, which is called ROS to action. Basically, it's a type of, it's suitable for tasks that are ongoing through time. So you have, first you take a action goal, right? So this is the input. So for example, I want to move to a position, such as, 5 meters away or in the kitchen, right? So it's a navigation goal. A navigation goal is a good example of an action, right? And then the action can be either rejected or accepted. That depends on the action server, right, which is on the robot. It might be busy with something else. It might be unable to perform it, and so on. Once accepted, you are getting feedback all the time. The feedback typically serves you to inform you whether you are on a good course, right? So if it's a trajectory for a robot arm, it's meant to show you, okay, that was your point in time where you should have had this position, but you actually have this position. So you can determine that the error is too high and you want to cancel the action because it doesn't make sense anymore. So this is the feedback, right? How well the action is going. And then there is the result once the action is finished. It can take any amount of time in theory, right? So the loop frequency, as I mentioned, is dependent on the model settings. So that's the answer, right? It's
so what you are saying is you have to predict that in 2 seconds the arm should be in place X, and you just check it whether it is actually there.
No, that's the beauty of it. So this is integration with state-of-art robot packages. So the navigation itself is realized with a state-of-art navigation stack. Yeah. Yes. So this is because, as I mentioned on the this slide, right? It generalizes, but typically performs much worse than state-of-art. Then why use it, right? Use it to engage a state-of-art behavior and check for its feedback, but only only interact with it on a high level, such as, okay, someone asked me to do something else. Let's cancel this action. But what happens with the navigation, so the obstacle detection, all that is in a high-frequency system without any kind of AI in the loop. So that's practical. That's actually what can work.
Nice, clever. Thank you.
Thank you.
Thank you very much for the presentation. I have this question. So you are using your robots in very complex environments, yes? In agriculture, probably in some rooms. So there is infinite amount of situations that may arise. On the other hand, you have this agentic framework. You have mentioned lang graph, so maybe you even have set of agents that collaborate. So again, you have infinite number of architectures, yes? So now the question is, how do you measure whether your architecture is better than some other architecture? And most importantly, how do you know whether you are going in the right direction? Yes, how do you know what to change in the architecture to improve your system?
It's a good question. So one, there is no learning in these scenarios except for in-context learning, which obviously is well known. And this kind of memory database is something that can offset this a little bit, right? And a vector database for domain knowledge as well, right? Or for experiences. So we have that on our issue list. So if you navigate to the GitHub, there are like good issues, very, very inviting for people to do research, to propose contributions. And for benchmarking, so we are building, as you see, a number of playgrounds, right? Which is good to benchmark things which require simulation, actually, because this is a complex interaction. It can't be computed in a kind of unit test. It needs to be run with a simulated environment. And then we will create a number of scenarios. They are not there yet, but this is the purpose of diversity of environments as well. So then you can use this R&D framework and have a bit of a work taken off your shoulders because you have the scenarios already. Right now, you can try it with different environments, but you have no automation to kind of determine the scores. You have to do it yourself, right? But this is definitely an item on the roadmap.
All right, so that was the last question for today. So let's thank once again Adam. Okay, we also thank all of you for your attention, for the questions, and it's time for the after party. So enjoy. Thank you.